Example 5.5, design the op-amp circuit so that vout is equal to 5V1 minus 2V2. Node voltages V1 and V2 are the input voltages. That have to be, one, they have to be summed. And another thing that they have to do here is you have to scale them, because one is 5 and one is 2. And we're going to need a sign change. So this immediately tells me if it's going to be summed, that means I have to have a summing amplifier. And if I have a sign change, that means I'm going to have a inverting amplifier. So my process goes something like this. So my thinking is as follows. So the first thing that I try to do here is that I use a table of designer amplifiers. In other words, I just look it up. Why reinvent the wheel if it's already been done? If you can't find it, build the op-amp circuit using multiple stages. So I did go in and look for it, and I wasn't able to find it. So that means in this situation, I'm going to have to build it. So I'm going to have to build this op-amp. Okay, so I had to build it. So one of the things that I started looking at here is that we clearly have a summing amplifier. So when I look at the summing amplifier, so looking at summing amps, they either have all positive or negative signs. So that means if I tried to do this, one either gets 5V1 plus 2V2, or you can have minus 5V1 minus 2V2. So if you see that, like here's one, just Googling it, there's a non-inverting one, so that gives me all positive signs. And then I have a summing one that looks like this. So you could see that I could either get only positive or negative. And the other thing here is that there is a difference, op-amp, but the gains are all the same. So that implies that it does not work. And just to give you a sense of what I mean here, here's what the difference amplifier does here. See, you could see that I only have one, so I have no choice but to design it. So in order to get the values that we want, okay, so remember, we want 5v1 minus 2v2. So that tells me that the first thing I got to do here is that I'm going to have to use some type of summing amplifier. And the one I'm going to use is that I'm going to use the summing amplifier, not the non-inverting summing amplifier, because it's just easier to do. So I'm going to use a summing amplifier. Why? Because it's easier. And what you're going to see here is that what happens here is that you get all negative signs. But I'm going to have to change the sign. So if I get all negative signs, I got to change the sign for 5v1. So that means in this situation, I have to, I'm going to use an inverting amplifier to get a sign change. Now we've calculated the amplifier in lecture before. So let's go. So I'm going to do this in 2 stages. So the first thing that I got to do here is that I got to come in and I'm going to do this in stages. So I'm going to start with the inverting amplifier. And I'm going to call this stage number 1. So when you're looking at this thing, here's what we're seeing. Here's the inverting op amp. So now I'm going to adjust this. So what I got to do here is that note that I have RF, the feedback resistor, and I have R1. So I need to scale this to get 5. So here I go. So the way I'm going to do this is I'm going to say I'm going to start off with some voltage, V1, node voltage. Then I have this resistor. Then I have my op amp. And you can see it being attached to the ground. And then I have my feedback resistor. And so now this is going to give me my output right here. So according to this, because this is op amp number 1, it's stage 1, I'm going to put a 1 here to remind you of that. So this has to be the feedback resistor divided by R1 times V1. So what I need is that I need to set the scale of RF and R1 to equal to 5. So what am I going to do? I'm going to set this guy to be 100K, and I'm going to set this one to be 20K. So then you see here that I'm going to get 100 divided by 20, which then gives me minus 5V1. So my first stage here was to get that sign change. Now I'm going to use the summing op amp here. So let's go look at that. So now I'm going to have a summing op amp. And this is what I'm going to call stage number 2. So when I look at the summing, this is what I see. So now what I got to do is I got to convert this. So one of my inputs right here is going to be my minus 5V1. And so when I sum it, note that I'm going to get a negative side, so I'm going to get a positive. And then I have a second node, which is V2. So if I just follow what's going on here, I'm going to call this R3. And then I'm going to call this R4. And you could see here is that this is going to connect here to the feedback resistor. And this is RF. And then I have to connect to my op amp now. Okay. So now when I look at this thing here, this tells me that this is going to be the output for the second stage. And if I look at this thing, this has to be minus, and then I have the sum of the feedback over R3, and I'm going to get minus 5V1 plus RF over R4 times V2. So you can see that what I have to do here is that I just have to scale these guys right. So now I'm going to choose the correct scaling. So I'm going to stick to RF being 100K. So if I stick to that, note that RF over R3 should be 1. So in this case here, I'm going to say that RF over R3, I want that to be 1. So then R3 must be 100K. And then I want the second scaling of RF over R4. I need that to be 2. So that immediately tells me that R4 has to be 50K. So if I put that all together, you could then see that I'm now going to have the out, so the output after stage number 2 is then going to be what? I'm going to have V out. Then I'm going to get minus, I'm going to have a 100K over 100K times minus 5V1 plus 100K over 50K V2, and you can see that this is going to give me 5V1 to V2. So in summary, this designer op amp looks like this then. I'm going to start off with V1, then I'm going to have my first stage, and this whole goal here is to invert the sign of the voltage. So you could see here is that this node right here is V out 1. So here's my 20K, here's my 100K, and then it's going to now go into the summing one. And when I look at the summing one, this is going to be V2 here. And when I look at this guy here, you could see that after this stage right here, I have a voltage of minus 5V1. So now I start my summing, then I start to sum these guys. And so here's my summing. And so the way I scaled them is that this was 100K, 100K, 50K, and then this guy is my output node. So if I look at my output node, you can see here is that V out 2 is then 5V1 minus 2V2.